Welcome back to Smarty Then. Today we're just outside Capitol Reef National Park. I'm Mike and I live with my partner Shar in our 2022 4x4 Sprinter that we built from the ground up as a home automated DIY home on wheels. Today I'm going to show you how to connect your Victron Energy system to Home Assistant using MQTT. It's a big step-by-step guide, so let's get to work. Okay, today we're going to integrate Victron Electrical systems into Home Assistant using MQTT. So if you have a Victron Electrical system and you use Home Assistant, by the end of this video, you should be able to pull all the entities that you want from your Victron system into Home Assistant so that you can view and monitor them. But we're also going to add bi-directional control so that you can send commands to the Victron system, like turning your inverter off and on or setting the shore power charge rate. If you saw my full dashboard tour video, then you've seen just how integrated everything is in our van. The goal of this van build was to have every system and every device integrated into Home Assistant so that we can view it all in one dashboard, both locally in the van and remotely on any device anywhere in the world, so long as the van is connected to the internet. I chose Victron components for a variety of reasons. They're really high quality, they have a great reputation, but they also have this concept of a central control center. And that's what they call their line of Cerbo products. This is sort of the brain of the system, and it communicates to all the other components like your inverter charger or your solar charger or an alternator charge controller. All of that information comes into the Cerbo, and you've probably seen Cerbo Touch 50s and Touch 70s in a bunch of installations. This gives you an interface to control and interact with your Victron Energy system. We have a Touch 50 under the bench, but it's there just for emergencies. I rarely touch that screen, but when I do, I'm usually accessing it remotely using the IP address over the network. It's just a lot easier than digging into the bench. Our system includes a multi+2 12-volt to 120-volt inverter charger, as well as a smart solar MPPT charger, a Lynx BMS, as well as a WakeSpeed alternator charge controller, and of course, a Cerbo GX. If you have a Cerbo GX or any of the Cerbo line, all of these instructions in this video should work for you as well. Victron has done a great job of allowing us to access the data from the electrical system and moving it into a home automation platform. They offer two ways to do this. One is called Modbus and one is called MQTT. Today, we're going to focus on MQTT because in my experience, I've found it's been much more reliable and much quicker, especially in bi-directional control. And I just like MQTT. I'm already using it in Home Assistant for other things, and so it makes a lot of sense for us to use it here. Both Modbus and MQTT offer bi-directional control, but again, I found it was faster controlling the Victron electrical system with MQTT. Okay, so what is MQTT? If you've never heard of it, it stands for Message Queuing Telemetry Transport. But basically, it's a simple protocol that uses a centralized server that they call a broker to allow devices to send all of their data into topics that are human readable. It's really pretty easy to look at and understand, and allows another device to pull those topics into another system. So that means we need a broker or a server that's running somewhere to let those messages come in from our Victron Energy system and then let Home Assistant pull that information in. Well, luckily, there's an add-on for Home Assistant called Mosquitto that's a really simple way to set up a broker. All right, there's a lot of steps to this process, but a lot of the things that we're going to do are things that you're either going to use for other projects later or you might already have up and running. The first thing we need to do is some network housekeeping. Both your Cerbo GX and your Home Assistant install should ideally have a static IP address, and this allows us to find each of those devices on our network at a reliably known IP address. To give each device a static IP address, the easiest method is just to go into your router and make a DHCP reservation. Generally, devices connecting to your Wi-Fi network or via Ethernet are going to get an IP address dynamically. In this case, we want to make reservations for these devices so that they get the same IP address every time. Because every router is a little different, I'm not going to go into great depth here, but you should be able to find instructions for your router online, and it should be fairly easy to make a DHCP reservation for both your Cerbo GX and your Home Assistant install. The first step is to activate MQTT on your Cerbo. In my case, it's a Cerbo GX and it's mounted in our bench. I also have a Cerbo Touch 50, but as I mentioned, I like to access that over the network in my web browser. Just makes things easier, but you can certainly do this at your touchscreen. If you are going to do this through a web browser, you'll need to know your IP address, which you should know since you just set a DHCP reservation in your router. And if you're going to do this like me, we're going to go to our IP address 192.168.50.160 in my case, and that's going to bring up the Cerbo interface. It looks exactly as it does on your touchscreen, and they offer these buttons here on the right side that allow you to navigate. But you can also navigate using your keyboard, so if you hit return, that should take you into the menu system. Then I'm going to scroll down to settings, then you can use the spacebar to enter that menu, and I'm going to navigate down using the arrow keys almost all the way at the bottom here. Then I'll use the spacebar to enter the services menu. There's 3 items in this menu that you need to activate. The first 3, it's Modbus TCP, MQTT on LAN with SSL, and MQTT on LAN plaintext. You can use the spacebar or the touchscreen to activate all 3 of these. Okay, now that those 3 things are activated, your Cerbo GX should be publishing MQTT information to its internal MQTT server. Next, we're going to take a look at some of the add-ons that we're going to need in Home Assistant to make all of this work. All right, there are 3 add-ons that we're going to use in Home Assistant to make all of this possible, and the first one is an MQTT broker called Mosquitto. So let's get that installed. Okay, so I'm going to log into my demo server called HA-Demo, and I'm going to go down to Settings. Then we're going to go into our Add-Ons menu. In the add-on settings, you see that we have ESP Home and a file editor. These are add-ons that we added for previous videos, and today we're going to add a new one by clicking the Add-on Store button down at the bottom. And I'm just going to search to make this easy. We're looking for Mosquitto, M-O-S-Q, and you see that it's Mosquitto with 2 T's, a play on MQTT. So we'll click on Mosquitto Broker here, and we're going to click Install. All right, once it's installed, the next thing we want to do is turn on the watchdog. This will just restart the add-on if it happens to crash. Okay, the next thing we're going to do is go over to the configuration tab here, and we're going to make a small change to the customize section. We're going to say active is not false, but we're going to make it true. Setting active to true here is going to allow us to do some custom configuration, which is important for integrating Cerbo GX into Home Assistant. The folder key here is already set to Mosquitto, and we'll leave that there, but we need to remember that it's Mosquitto. We'll click Save at the bottom, and then we'll go to Info and click Start. Once this starts, we'll be running an MQTT broker on our Home Assistant server, which in my case is a Raspberry Pi. The next of the 3 add-ons that we need to install is called Studio Code Server, and this will allow us to modify our configuration files for Home Assistant. So we'll hit the back arrow here, and I'm going to search the store for Studio, and we see Studio Code Server. So I'll click Studio Code Server and click Install. While this installs, I will mention that there are other ways to modify configuration files for Home Assistant, but Studio Code Server has a bunch of features that make it a little easier to edit your files, and they have an autosave feature, so overall I like it better than a simple text editor, although that is an option. All right, once that's installed, we're going to again turn on the watchdog, and in this case, we're also going to show in Sidebar, which will show Studio Code Server here on the left. Then we'll click Start. All right, the final add-on that we need is SSH. This will allow us to SSH into our Home Assistant server from Home Assistant and access the file system. There are other ways you could do this, but this will keep us inside Home Assistant for this entire process. So we'll click the back arrow here. All right, so I'll search for SSH, and we'll click Advanced SSH and Web Terminal. Then we'll click Install. There are other SSH add-ons available in the community store, but this one should be available to you without having to do any extra steps. Okay, as usual, we'll turn on the watchdog and show in Sidebar so that we can access it over here on the left. Then we need to go to the configuration and set a password. I'm just going to set it to admin. You can set it to whatever you want. Then we'll click Save, go back to Info, and click Start. The next thing we need to do is to bridge the MQTT server running on the Cerbo GX to the one that we just set up in Home Assistant called Mosquitto. To do that, we're going to use the SSH terminal add-on that we just set up. So we'll open the terminal, and we're just going to do some simple file editing here. You could do this in an actual file editor, but this is only a couple steps, and it's done right here in Home Assistant. So if you remember in the Customize section for the Mosquitto Broker add-on that we added to Home Assistant, the folder was listed as Mosquitto. So we need to create that folder on our file system, and to do that, we're going to go to the terminal here. We need to make this directory called Mosquitto in the share directory. So we're going to change directories to /share. And if we want to see what's in that directory already, we can type ls and see that there's nothing there. So we're going to make a directory by typing mkdir, and we're going to call this Mosquitto. Now, if we type ls for list, we should see the Mosquitto directory there, and we're going to change directories into that directory by typing cd/Mosquitto. Okay, so now we want to add some custom configuration to the Mosquitto broker, and that's going to happen in this folder. So we need to create a configuration file. To do that, we use the command touch. We're going to call it victron.conf for configuration. Then we hit return. The touch command simply creates a file. It's an empty file, but now we should have a file called victron.conf. If we type ls and hit return, we'll see that in the Mosquitto directory, we have victron.conf. So now we need to edit that file. And to do that, we're going to use the nano command. So we type nano and then victron.conf, and this brings up a rudimentary file editor. Right now we can see that it's empty. So we're going to add text to this file to configure a custom bridge between our Cerbo GX and our Home Assistant Mosquitto broker. To do that, we're going to make a new connection by typing connection, and then we're going to call it Victron. On the next line, we'll type the address of the server that we're trying to talk to, and that should be the IP address of your Cerbo GX. So we type address, and then we need the IP address for your Cerbo. In my case, it's 192.168.50.160. And then we use the port number 1883, and that is the default port number for MQTT. I'm not going to get into too much detail with the next 3 lines of this configuration, but they basically tell the Mosquitto MQTT broker how we want to synchronize the topics with the Cerbo GX. The first one's for notifications, and we want those to come in to Home Assistant. The next one's for read, which we want to go out to the Cerbo GX. And finally, we have a write topic that's going to go out to the Cerbo GX as well, using the top level topic Victron. Once your configuration looks like mine, but with your Cerbo GX IP address in the second line, then we're going to click Control X to exit. And then at the bottom, it says, you have a modified file. Would you like to save it? We'll type Y for yes. And then it asks the file name. We'll leave it as is and click Return to save. Now we can go back to our settings, go to the add-on. If it's not running, we'll click Start. If it's already running, we'll click Restart. Now that the Mosquitto MQTT broker add-on is up and running, we need to configure the integration. We'll click Settings and go to Devices and Services, and you should see MQTT is discovered. We'll click Configure and Submit. The next step is to add an MQTT user. We're going to add a user to Home Assistant so that we can finally take a look at the data that's coming in from the Cerbo GX via MQTT to Home Assistant. Before we can add that user, we need to click on our name here on the bottom left, and we need to turn on the advanced mode. So we click that button here, and now we can go back to Settings and go down to People, and then we'll see the Users tab. If you don't see the User tab, you need to go back to the bottom left, click on your name, and make sure advanced mode is on. Okay, we're going to add a new user by clicking Add User at the bottom right. And first we need a display name. I'll just call this MQTT user. And the actual username, I'm just going to leave MQTT. The password, I'm going to leave MQTT as well. I'm going to turn on local access only for this user. And that means this user can only access this install on the local network. Now that we have an MQTT user available to us, I'm going to show you a piece of software that lets you explore what's going on the MQTT server. And that software is called MQTT Explorer. You can go to mqtt-explorer.com and download this software for free. Okay, now that you have MQTT Explorer installed and running, we're going to open it up and create a new connection so that we can explore the MQTT broker on our Home Assistant server. So we click Add New Connection, and we'll call this HA Demo in my case. And then the host is the IP address of our Home Assistant server. Back in the first step, we set up a DHCP reservation for your Home Assistant server, so you'll want to use that IP address. But if you don't know that IP address, no worries. We just go over to your Home Assistant server, click on Settings, we'll go down to System, we'll go to Network, and I'm going to click these 3 dots and get the IP information. This IP address is the IP address of your Home Assistant server. So I'll copy that IP address, go back to MQTT Explorer, and we'll paste that in the host field. The port will stay 1883 as that's the default port for MQTT. Then in the username and password field, we'll use the username and password we just set up in the new user we created in Home Assistant. In our case, it was MQTT and MQTT. Then we'll click Connect. And if we've done everything right, you should see Victron appear at the top level underneath the IP address of our Home Assistant server. So if we unfold the Victron topic, we'll see the N topic underneath for notifications, and we'll unfold that. And then we're going to see the ID for our Cerbo GX. Victron calls this the VRM portal ID, and this ID is going to become really important when we start to make entities in Home Assistant. So if we click on that ID, you can go over to the right panel here and copy it from the topic. I'd paste that somewhere safe because you're going to need that later when we configure those entities in Home Assistant. Occasionally you'll see topics flash here, and that means there's new information coming into those topics. So under this top level ID, we're going to see all of the information coming in from the Cerbo GX. And if we open our system here and we open 0, we can scroll down to DC, and let's open the battery. And if we click on SOC, we can see the value of our state of charge here. On the right side, you can see the topic path. So it starts with Victron and then the ID of your Cerbo, and then we go into System, 0, DC, battery, state of charge. Every one of the pieces of information that comes in from the Cerbo will have a path like this, and these are the paths we're going to use to configure MQTT entities in Home Assistant. The next thing we need to do is create a keep alive automation in Home Assistant. Because we bridge the Cerbo GX MQTT broker and a Home Assistant broker, we need to ping the Cerbo GX broker every so often to keep it alive, to keep sending us that data. So we'll go into our Home Assistant install, click Settings, click Automations and Scenes, and we're going to create our new automation. All right, if this is your first look at automations, this will be a good intro because it's a pretty simple one. First, we need to set when. When does this automation happen? And we're going to add a trigger. We're going to use a time-based trigger. So I'm going to use a time pattern because I want this to trigger every 30 seconds. So we can set up a certain pattern here. We're interested in seconds, and we're interested in every 30 seconds. If I just type 30, it's going to trigger on the 30th second of every minute. But if I add a slash to the front of this, it's going to trigger every 30 seconds, which may not be the 30th second of every minute, but it will be reliably every 30 seconds. All right, so that's our trigger. Every 30 seconds, we want to do something. Well, what is it we want to do? We'll go down to the Then Do section. We're going to click an action. The action we want is an MQTT publish action. So we'll find that by typing MQTT, and we'll choose the publish action. So this is the path of the topic that we want to publish to. And it's important that you replace this part here that says your VRM portal ID with your ID. So we're going to delete everything, including those brackets, and paste your ID here. And then in the payload, we're going to type an open curly bracket and a close curly bracket. Then we'll click save, and then I'll call this MQTT-Victron keep alive. That should give me a lot of nice things to search for later when I have a lot of automations. Then we'll click save. So basically what this automation does is send a ping to the Cerbo GX MQTT server every 30 seconds to keep it alive or keep it publishing information. This is a really important step because if you don't have this, eventually your MQTT information will stop updating from the Cerbo GX. Okay, we finally get to add MQTT entities from the Cerbo GX to Home Assistant. Just kidding. We actually have one more tiny step before we do that, but we're going to do both of those things in Studio Code Server, which is one of the add-ons we added a while back. So we'll click Studio Code Server on the left side here, and that's going to load this file editing interface. So this is the file structure of Home Assistant. And if you've never looked at this, there are a couple things in here that we need to look at. One is the configuration.yaml. This is the main configuration file for your Home Assistant install. Your configuration.yaml may not look just like mine because this is a very fresh install of Home Assistant with not much going on yet. Configuration.yaml is a place where we can make major configuration changes to our Home Assistant install. Technically, you could write a lot of configuration in this one file for your whole Home Assistant install, but it's going to turn into a mess eventually once you have a bunch of configuration that you want to have done. So there are means by which you can simplify and organize this. One of those ways is to include another file. And you can see here there's some default ones already set up, like automations, scripts, and scenes, and they use the syntax !include, and then the name of another file, and then you'll see over here that file exists to the left. And if I click on automations.yaml, you can see the configuration for the automation that we made just a few minutes ago using the time pattern of every 30 seconds publishing to MQTT using this topic. Of course, you've replaced this portion with the ID for your Cerbo. All right, back to configuration.yaml. So you can use this technique of adding additional configuration types at the bottom of the file here and including another YAML file at the top level of this directory. But there's another method you can use to keep your configurations organized, and that's called packages, where you can pull in entire folders full of configuration. I like to use packages because it helps you keep configuration organized by ideas or topics. So in this case, we want to configure things for Victron, and they might be different entity types, but I want to keep them all together in one file. So when I go to work on the Victron system, I can look in one place. So to do that, we're going to add Home Assistant, and then tab in and type packages, Then we'll use !include _directory name, and we're going to call packages. And on the left side here, we'll click New Folder and add the Packages folder. So now Home Assistant is going to include this directory called Packages and any configuration that's included inside there. So inside Packages, I'll create a folder called Victron. And inside the Victron folder, I'm going to create a file called Victron.yaml. Now, anything I add to this Victron.yaml configuration file will be included in the main configuration for Home Assistant without cluttering up the configuration.yaml file. Okay, now we can finally create some entities from our Victron Energy system in Home Assistant. And to do that, we're going to configure them manually using the MQTT integration. So I'm going to paste the configuration for our van here, and then we're just going to talk about some of these entities and how they work. And at the top here, I'm using the # to create a comment, and I'm just saying that these are the Victron MQTT entities. You may already be using MQTT if you're using things like Zigbee to MQTT or any other integrations that have MQTT, and they may be auto-discovered. But because there's no MQTT Victron integration already built for Home Assistant, we're going to manually configure MQTT entities for our system. The first thing we need to do is tell Home Assistant that we want to use the MQTT integration. So we type MQTT : return, and we tab in. Then we're going to use a variety of different entity types like numbers, switches, and sensors to bring all the information from Victron into Home Assistant and give bidirectional control of things like the inverter. I've got controls here at the top, and these are things that are going to work in both directions. The first entity I'm defining here is a number entity, and this literally stores a number. And since it's an MQTT number entity, it can publish its state to a topic in MQTT, and it can read its state from MQTT topic. Most of the entities in this configuration file are going to have the same elements, so let's talk through this one as an example. The first field is a name, so we're going to give this a friendly name. I call this the Victron charge amperage, and I'm going to give it a unique ID. I like to give every entity a unique ID because that allows you to modify some of its attributes directly in Home Assistant. I would just get in the habit of using a unique ID anytime you manually configure an entity in Home Assistant. To do that, I just go to uuidgenerator.net and I just pull uuid here, which is a randomized string. You can copy it here and then go back to Studio Code Server and we can paste that unique ID. Be sure to use a unique ID for every entity. We don't want any that match. This website makes it easy because you can see you've already copied this and you simply need to refresh the page to get a new one. Okay, back to Studio Code Server, we can see we have two lines here called command topic and command template. The command topic is the MQTT topic that we want to publish a new state to anytime our number entity is changed in Home Assistant. To figure out which topic you need to be publishing to, you can refer to this GitHub page that Victron publishes that documents all the paths and what the values mean in Venus OS, which is the OS that's running on your Cerbo. I'm using the path AC active in current limit, and it looks like that's been deprecated in favor of this path, so I'd probably use this one if I were starting over, but this works fine for now. I find the easiest way to find the full path is to use MQTT Explorer. We know we're looking for current limit, so I'm going to go back to MQTT Explorer, so I'm just going to start typing current limit to see what filters out. So you can see I'm using active in, and there we go, there's the current limit. And if I click on that element, we can see the full path here. And if we click this button, you can copy that path to the clipboard. So you go back to your configuration file and paste that path here under the command topic. When you paste this topic path from MQTT Explorer, we're pasting the path that is coming from Victron. And in the command topic, we want to write those values to Victron. So we need to make a slight change here after Victron. Instead of N, we want that to be a W. We're writing this value out to Victron. Okay, now we need to look at the command template. A template allows you to use Jinja to process a value before that value is sent. So we're going to take the value of our number entity and we're going to filter it to make sure it's a float. And then we're going to insert it inside this piece of JSON. Victron's MQTT system expects key value pairs. And so we don't just want to send a raw value, we need to send a key and a value. It's a little confusing because the key here is value. So we're setting the value equal to the value of our entity in Home Assistant. This will make a little more sense if we look back at MQTT Explorer and see the value that's currently coming in. And if we look at the current limit, you can see this is written as JSON. So we use curly braces to contain a key and a value. The key is value and the value is listed here. So we want to publish it in the same way. So we're going to publish value in quotes, colon, and then we're dynamically inserting the value of our number entity here. And so this entire string is what will be sent to the command topic when this value is updated in Home Assistant. The state topic is almost exactly the same as the command topic, except for the second part of the path is an N instead of a W because we are reading notifications from the Victron side. Again, we're going to use a template to set the value of the entity in Home Assistant. A number entity doesn't need a key value pair in Home Assistant, it just needs a raw numeric value. And when a value comes in from MQTT, it's stored in something called the value underscore JSON. And because that's coming in as a key value pair, we need to tell it which value we want. So we're saying here in our template that we want to take the value JSON dot value. And if we look back at MQTT Explorer and we click on our current limit, we see that we want to take the overall JSON value that comes in, and we want to take the value key and tell me what that value is. And that value is going to be used to set the value of our number entity in Home Assistant. So basically, by having a command topic and a state topic, we have a bi-directional control. And this entity is for Victron charge amperage. And this allows us to set the amperage draw when we're on shore power. And we want that to work both ways. So if we change that on the Cerbo GX touchscreen, we want that to update in Home Assistant. And if we update it in Home Assistant, we want that to update on the Cerbo GX as well. The number entity has some other values that we can set, like a minimum and a maximum value. And in this case, our multiplus can take in up to 30 amps. So I set the maximum to 30 and I set the minimum to 9.5. It's kind of arbitrary, but I wanted something under 15 amps if I wanted to throttle down the charging while we're on shore power. The step value is 0.5, meaning the slider in Home Assistant for the number entity will jump in half integer increments, 1, 1.5, 2, 2.5, etc. Finally, we're going to define a device. And what this is going to do is allow us to take all the entities in this configuration file and make sure they become part of one device in Home Assistant. So for this first one, I'm going to set the device identifier as Cerbo GX, and then I'm going to set the manufacturer to Victron Energy, the model is Cerbo GX, and the name is Cerbo GX. So this first entity is kind of unique. It's a bi-directional control using a number entity in Home Assistant to set the shore power charge amperage level on the Cerbo GX. Next, we're going to define 3 switches. Again, these are bi-directional, allowing us to control things on the Victron side and bring that information back into Home Assistant if those things change on the Victron side. The first one is for the inverter, and I'm going to give it the name inverter, a unique ID using the UUID generator site. Again, we have a state and a command topic, and those 2 topics are almost exactly the same, except for the N and the W. So I know that the multi-plus is using VE bus, so we can go back into our Victron system here and look at the VE bus. And the ID of our multi-plus on the Cerbo is 276. It's the only one we have. So we'll scroll down 276 and we'll look for mode. And we can see that the current value is 4. If we reference the Victron GitHub site, we can scroll down and find mode and figure out what the values mean. 1 means charger only, 2 means inverter only, 3 equals on, and 4 equals off. So since we're just trying to define a switch to turn the inverter off and on, I'm just going to use the values 3 and 4, which represent on and off. So state on means if we get the value 3, that the inverter must be on. We're reading this state from the Victron side, and state off, if the value is 4, that means the inverter is off. The payload on and off are the values that we're going to send when the switch is changed in Home Assistant. So if we're turning the inverter on, we'll send the value 3, and if we're turning the inverter off, we'll send the value 4. Then we're going to set optimistic to false. This means when we flip the switch in Home Assistant, we're not just going to assume that it worked. We're going to wait for the state to be updated. And if the state is on, then the switch in Home Assistant will be turned on. If optimistic is set to true and you turn that switch on, it'll send the command to the Cerbo GX, but we're not waiting for confirmation that it actually worked. I think it's important to leave optimistic set to false, and this will also ensure that if you turn the inverter on using the Cerbo GX, that the state of the switch in Home Assistant will be updated. Again, we're going to use the device identifier and set it to Cerbo GX, so that it groups this entity with all the other entities in the device in Home Assistant. After the inverter switch, we have 2 more switches, one for each of the relays on the Cerbo GX. I'm using one of those to turn charging off and on for our tablet in the kitchen. I'm using the second one to control the wake speed, alternator charge controller, and turn it off or on. These 2 relays are configured almost the same way as the inverter above, except we're using the values 1 and 0 to turn the relay on and off. 1 means on and 0 means off. All right, next we're going to get into some sensors. I have a long list of sensors here that are being pulled in from the Cerbo GX, and these are all moving in one direction. We're just taking the information from the Cerbo GX and pulling it into Home Assistant so we can use it there. So we need to define the sensor integration, and then our first one is for DC load. And this is a system level stat that I want that is our DC power consumption. So I'm going to look for a pathway here in the documentation that has to do with DC system power. And if I click on system at the top here, we can scroll down to the DC section and see that there's a DC system power path. And if we go over to MQTT Explorer, you can scroll down your system, the 0, the DC, the system, and we can find that there's a power value right here. If you're having trouble identifying which pathways you should use for your sensors, sometimes it's helpful to go take a look at your Cerbo GX screen or log in remotely and just check the value here to make sure it's the same. So we can look at the DC power down here and the DC power here, and we see it's the same value. So we know this path here is the correct path for our DC system power. And then again, we give it a friendly name, and we're calling this DC consumption, a unique ID, and then we could define an icon. You don't have to do this here. You could do this inside of Home Assistant, but it's kind of nice to have this done in your configuration file. Home Assistant uses the material design icon library, and you can browse that library by going to pictogrammars.com/library/MDI, and we can look for something like a lightning bolt. And you can copy the name by clicking it right here. If we go back to Home Assistant, we would type MDI : and paste the name of that icon. And you can even see a preview of the icon right here. And this is one of the advantages of using Studio Code Server. Next, we're going to define a device class. This is helpful because Home Assistant understands classes of devices and then which unit of measurement you're using. And that's helpful for conversions inside of Home Assistant. So we're going to define this device class as power, and then its state class is a measurement. The unit of measurement is in watts, which is capital W. I'll leave a link to the documentation for device classes below, and on that page, you'll find a list of all the supported classes for sensors, as well as their units of measurement. Next, we need to set the value of our sensor. And again, we're using templates because we just want a raw value for Home Assistant, and if you remember, MQTT is storing key value pairs. And we're going to tell Home Assistant that we want to use the value key, and then we're going to use a filter to round that value off. Finally, I'm going to add the Cerbo GX device identifier to group this entity into the Cerbo GX device in Home Assistant. A majority of the sensors in the rest of this configuration look a lot like this. They may have a different device class and a different unit of measurement, but they'll all have a state topic, a name, a unique ID, and an icon. One that looks a little bit different is the next one, and this is our inverter mode. And this one looks a little bit different because Victron reports the mode of the inverter as a number, but those numbers are associated with a plain text description of the state. We're using the same state topic as the switch above, but in this case, we're going to use value templates to turn those numbers into human readable states so that we can display that in Home Assistant. Value templates use Jinja to process information, and here we're using a caret to show that we're going to do a multi-line template. Basically, this template says that if the value of our JSON that comes in equals 1, then we want to output the words charge only. If the value is 2, we want to output the words inverter only. If it's 3, the inverter is on, and if it's 4, the inverter is off. And if we get none of those values, we're going to set the sensor equal to error, no data. So the state of this entity named inverter mode is going to carry a text value that either says charger only, inverter only, on, off, or error, no data. I'm not going to do a deep dive on templating, but we're using a basic if-else logic here. We're checking to see if the value is 1 first. If not, is it 2? Is it 3? Is it 4? And else just do this, and then we end our if evaluation. And finally, we add the device identifier. So now we'll know the mode of our inverter in plain text instead of just a number value. Okay, I'm not going to go through the rest of my configuration line by line, but I will link to it in the description below so you can open it up and take a look for yourself. Just keep in mind that every system is different and has different components, so not all of my configuration will work for you. And even if you do copy and paste some of my configuration, you're going to need to update your VRM portal ID in the paths of these sensors. You may also have a different ID for your inverter, for instance. So double check your paths and use MQTT Explorer to check against your Cerbo GX to make sure you're getting the data that you expect for these sensors. Again, I will link to my description down below so you can have a look through, but we're including everything from the inverter, the solar charge controller, the wake speed, alternator charge controller, as well as our tank levels. All right, now that we've added a bunch of sensors to the Victron.yaml configuration file, what do we do from here? Well, the first thing we need to do is do a system restart. Anytime you modify the configuration.yaml file, you need to restart Home Assistant. This will also load all these MQTT entities from our Victron.yaml configuration file. So we'll go to Developer Tools, and we'll go to Restart, and then we'll click Restart Home Assistant, and then Restart. Okay, so to see all of the entities that we've created in the configuration file, we'll go to Settings, Devices, and we should see one device under our MQTT integration, and that device is a Cerbo GX, and it's grouped together all of the entities that we've created in the configuration file, including the controls at the top and the sensors below that. Okay, so we have a device with all these entities, but now we need to make this useful on a dashboard. So let's look at how we might add some of these entities to a dashboard. I'm going to go over to our van dashboard. Might look familiar from previous videos, and I'm going to click Edit, and I'm going to add a new section here, and we'll just call this Power. Let's set the icon to a lightning bolt, and the URL in the browser will be Power, and then I'm going to set the type of view to Sections, and I'm going to click Save. So now we have a Power tab on our van dashboard. So let's add our first entity to the dashboard. I'm going to click Add a Card here, and I'm going to look down for the gauge card. And I'm going to start typing Cerbo GX. And you can see that's going to filter all of the sensors that start with Cerbo GX. But I know we have one called State of Charge. So I'm going to add SOC, and we see we have sensor.cerbogx battery SOC. So let's click that there. And now we can see our state of charge on a simple gauge. We can name this gauge if we want, SOC. We've already set the units to percent in the configuration, so there's no need to set that here. The default minimum and maximum is great because the defaults are 0 and 100, which is perfect for a percentage. And then optionally, we can define the severity. This will allow you to define when the gauge turns different colors at different values. So we can say we want it to be green if we're above 75%, and we want it to be yellow if we're above 30%, and red from 0. So this basically means that we'll be red from 0 to 29, and yellow from 30 to 74, and green from 75 to 100%. Okay, so then we'll click Save, and now we have a gauge on our dashboard. Another thing we might be interested in is our solar yield. So I'll add a card here, and I'm just going to do a tile. Okay, then we'll choose Cerbo GX Solar Power, And we can adjust some of the appearance parameters here. Let's just name this solar power. And it already has an icon from our configuration, and we'll leave the default color. And that looks pretty good. We can see our solar power coming in. Another thing we might be interested in here is a switch for our inverter. So let's add another card, and we'll use the button card. All right, let's choose our entity. We'll go with the Cerbo GX inverter switch, and we're just going to call this inverter. I don't think we set an icon in the configuration, so it's a default switch icon. I like to use this one called power plug battery. And so we'll click save. And then we'll click done. Now we have a dashboard with our state of charge, our solar power, and an inverter. And if we click the inverter switch, it will turn on. From here, you can imagine building any kind of dashboard you want. We sprinkle these entities throughout all of our dashboards, especially solar power and the state of charge of our battery. All right, I've got two bonus topics for you here, and the first one is about automation. Now that we have all these entities pulled in from the Victron Energy system, we can start to automate. We can take the value of one entity and cause something else to happen. All right, so let's create an automation that turns the inverter off if it's been idle for a certain period of time. So we'll go to Settings, then we'll click Automations and Scenes, Create Automation, and Create New Automation. First, we need a trigger. What causes this automation to happen? What we want to know is when the wattage draw of the inverter drops below a certain level for a certain length of time. So let's add a trigger. We're going to look at an entity, and we're going to look at the numeric state of our inverter wattage draw. So let's find that entity. What I'm going to look at is the AC consumption, so the wattage being used on our inverter. That sensor is called Cerbo GX AC consumption that we created in our configuration. So we'll choose that entity here, and we're going to evaluate when the wattage draw of the inverter drops below a certain number. And I'm going to say below 20, because I find that our inverter sits at right about 20 watts when it's idling, because we're not using any of the power saving features on the Multi Plus 2 at the moment. So when it's below 20, we're going to cause something to happen. But I'm also going to add a for value here, and we're going to say it has to be below 20 for 30 minutes. So if it's sitting idle for 30 minutes, then this automation will trigger. So that's summarized right here. When Cerbo GX AC consumption is below 20 for 30 minutes, then this automation will go on. Then we need to set an action. It's the then do part of the automation. What are we going to do when this automation is triggered? Well, we're going to turn the inverter off. So I'm going to add an action, and I'm going to look for switch. And I'm going to say switch turn off, and I'm going to choose an entity. I'm going to choose the entity Cerbo GX inverter, which happens to be right at the top here, and I'll scroll that up. So now this whole automation reads that when the Cerbo GX AC consumption is below 20 for 30 minutes, then we'll turn off the inverter. And we'll click save. Then we'll say Cerbo GX inverter off when idle, and we'll click save. Now, anytime your inverter has been sitting idle for a certain period of time, it should turn itself off. This is just an example, but hopefully you can imagine how you can start to automate against all the entities for your Cerbo GX. Okay, one more bonus topic for you, and this is about the recorder. Home Assistant records every state change of any entity into a database. And as you can imagine, the state of the solar charge, for instance, is constantly changing. So every time that value changes, it's being written to a database. Now, if that's a value that you don't really need to see a history on, then there's no sense in overworking your server and writing so many changes to your media. If you're using a Raspberry Pi and a micro SD card like I am, there could be a lot of extra writes happening for all the state changes across all these entities. And we've just added a bunch of new entities for our Victron system. And a lot of those things I don't really care about the history for. So we're going to ask Home Assistant to exclude some of these entities from the recorder and save ourselves some write operations on our SD card. To do that, we're going to go back to our Studio Code server and go back to our configuration.yaml, and we need to add a line here to add recorder configuration. So we'll type recorder : and then exclamation include, just like the ones above, and we'll add recorder.yaml. Okay, after we've done that, we need to actually add the recorder.yaml file. So we'll create a new file here, and we're going to call it recorder.yaml. I decided to change two configuration options for our recorder, and that's primarily because we're using a micro SD card in our Raspberry Pi, and I just want to take it a little bit easy on that card. So I changed the purge keep days to 7, so after an automatic purge of database information, we'll keep 7 days of records instead of the default 10. I also changed the commit interval from 5 seconds to 30 seconds. This just reduces the write frequency to the database. The next thing we want to do is tell Home Assistant which entities we want to exclude. So there are several ways you can exclude or include entities from being written to the database, and one of those ways is entity globs, which means you can use a wildcard to filter for all entities that include a similar text string, or you could just make a list of entities. Let's say we wanted to exclude all of the entities that came in from our Cerbo GX. We can write it like this, sensor.cerbogx, and then use the asterisk as a wildcard so that it'll exclude anything that starts with Cerbo_GX_. That would prevent Home Assistant from writing all of the entities that we just created into the database. We can add individual entities under the entities header if we only want to exclude a couple entities from being recorded to the database. So if we add the entity for the battery state of charge, we'll no longer get the battery state of charge written to the database. I highly recommend you think about the entities that you really need a history for. You may want the history for the state of charge of the battery, but perhaps you don't need the history for the voltage of the battery. And so I would go through all those entities and list the ones here that you want to exclude. After you restart Home Assistant, you'll now be saving on write operations, and the size of your database will be smaller. Okay, so we have successfully integrated our entire Victron Energy system into Home Assistant using MQTT with bi-directional control so that we can do things like turn our inverter off and on. I know there were a lot of steps along the way, but I think you'll find things like Visual Code Studio that we installed as an add-on useful later in your Home Assistant development. If you get stuck along the way, jump back into chapter markers and make sure you didn't miss anything. But if you have any other troubles, drop some comments below and we'll do our best to help out. I hope you have fun integrating your electrical system into Home Assistant, and until next time, safe travels.